Our last section in Chapter 11, and therefore our last section before our first exam, is 11.7, which is Applications of Quadratic Equations. This is our first word problem section. There isn't really a new concept here, so much as we're learning how to do word problems. So rather than talking about a new concept, we're just going to talk through a few different word problems to try and get a feel for how word problems work. Let's start with this one. If the square of a positive integer is added to 3 times the integer, the result is 54. Find the integer. So I know from looking at this sentence that I have one thing that I'm dealing with, one integer. So I'm just going to name it. I'm going to say that the integer, I'm going to name it x. So I am talking about if the square of a positive integer, so the square of x, x squared, it's added to, so I have a plus, 3 times the integer. 3 times x, 3x. Then the result is 54. That looks like just like something that we handled in the last section. In order to get it in my right form, I say x squared plus 3x minus 54 equals 0. Then I just have to factor that. All I need to remember is that 54 is 9 times 6. This is positive, so the bigger one, the 9, is going to be positive. So I have x plus 9 times x minus 6 is 0. So by what we talked about in the last section, x is either negative 9 or positive 6. Then I look back at the question, I see that it requires that x is a positive integer. Negative 9 is not a positive integer. So our integer is 6. And we're done. The hard part is always getting to here. Looking at the words that we're given and figuring out how to make them into an equation. That's what makes word problems different. And also what makes them really challenging, because it can be very hard to figure out how to get to that equation. Let's try another one. The product of 2 consecutive odd integers is 63. I now know I have 2 integers. So let's name them. 2 integers. I'm going to name them A and B, just for fun. I know that their product is 63. A times B equals 63. I don't know how to solve that equation. But I also know that these are consecutive odd integers. So I'm going to think of some consecutive odd integers that I know. 3 and 5 are consecutive odd integers. 5 and 7 are consecutive odd integers. What all the consecutive odd integers I can think of have in common is to get from one to the next, you add 2. So A plus 2 equals B. Let's check. If A was 5, adding 2 would give me 7, which is, yes, my next odd integer. So for any pair of consecutive odd integers, I can have that statement. Alright, now I have 2 equations and 2 unknowns. I should be able to solve this. I'm going to take this equation and plug it into this one. So I know that B is equal to A plus 2. So where I see this B, I can substitute A plus 2. Be careful to use parentheses. A times A plus 2 equals 63. Now when I see the parentheses, I know I've got to distribute. That's why it's so important to have the parentheses. So I have A squared plus 2A equals 63. Yes, perfect. That looks like something we could have dealt with in our last section. A squared plus 2A minus 63 equals 0. Okay. Now we've got to try and factor that. Our important thing to notice is that 63 divided by 7 is 9. So 9 and 7 are things I can multiply and get 63, and they have a difference of 2. Since this has a plus, the bigger one had better be positive. So a plus 9, a minus 7 equals 0. You can multiply that out and make sure that it's true. So a is negative 9 or positive 7. It didn't technically say that these had to be positive. So both of these are rational choices. Didn't say that these were consecutive positive odd integers, just that they're consecutive odd integers. So a could be negative 9, it could be 7. If a is negative 9, b is what? Negative 9 plus 2, negative 7. Likewise, if a is 7, then b is 9. So we have two choices for what a and b could be. That's perfectly all right. Let's do one more of these. A lot of applications are going to involve geometry, and they're going to require us to think about the geometry formulas that we remember from our previous life. The length of a rectangle is twice its width. The area is 72 square inches. Find the length and the width. So I have two things. Length. I'm going to name the length L. And width. I'm going to name the width W. Now, I'm going to think back to my geometry class, my freshman year of high school, and what I learned about rectangles. I remember that area is equal to length times width. Area of a rectangle, that's something you should know. Area of a triangle, that's something you should know. Our basic geometry formulas we should remember. Okay, so that's our our area formula. I know that the length of this rectangle is twice its width. So I know that L is twice as big as W. So I know that L is equal to twice W to W. And I know that area is equal to length times width and is equal to 72. So L times W is equal to 72, and L is 2W. Let's plug that in for L there. I have 2W squared equals 72. I don't even need to use my fancy techniques that I have. I'll divide both sides of these by 2. W squared is equal to 36. I'm going to think to myself, what squared is 36? W is 6. Technically, solving this equation, W could also be negative 6, but I have never in my life encountered a rectangle with negative width, so for sure my width is 6. Then I need to find my length. I plug that back in up here. My length is 2 times my width. L is 2 times 6. L is 12. W is 6. L is 12. I'm good. Alright, there are lots of different word problems that you can look at. You will look at a selection in your book. All of them have different rules, but they all have the same fundamental concept, which is you take the words you are given, you make them into equations, you solve those equations using our quadratic techniques. And I highly, highly recommend very carefully going through the homework for this section, because that'll get you a lot of good practice making these equations. And the homeworks are a super valuable resource.